There you go. We're just getting organized here, folks. So we'll just test. We're good. All right. I'll just wait till I get my final okie dokie from our IT AV super guru. Okay. Well, good evening, folks. For all those out there on the Zoom and on YouTube, welcome. I'll just quickly say hi to a couple people. Jim McGregor, Jerry's on there, Catherine, Corinne, Leo, Mario Ortiz, Kim, Kamala, Dale, Michelle, and Paula and Gord. So good evening, everybody. My name is Dennis Lyons. I'm the president of the RASC Winnipeg Center, and I'd just like to welcome you all to our monthly meeting. And first, I'm going to do our land acknowledgement. The lands from which our members and guests are joining us are located on the original lands of Anishinaabe, Cree, OJ Cree, Dakota, and Dene peoples, and on the homeland of the Métis Nation. We respect the treaties that were made on these territories. We acknowledge the harms and mistakes of the past, and we dedicate ourselves to move forward in partnership with Indigenous communities in a spirit of reconciliation and collaboration. So again, good evening. Our first speaker tonight is Gail Wise, and she'll be talking to us about Caprin and the Ovine. And I'm sure I roasted that name, that title. Yep. Please welcome Gail Wise.
Everyone, can you hear me? Yes. Okay, so you know how bears are ursine and cats are feline? Did you know that goats are caprine and sheep are ovine? I learned a new word myself putting this one together. And that makes sense because the goat constellation is Capricornus. Capricornus has been recognized as a goat since Babylonian times, and it's easy to see why. I mean, well, this could be his, well, that's obviously, well, don't you see what that is? Well, I don't know. Capricornus, the sea goat, looks kind of like an upside down hat, the kind my great auntie Martha used to wear. It's made up of dim stars that are mostly third and fourth magnitude. It is just east of Sagittarius and south of Aquarius, and there is Capricornus. As autumn goes by, Capricornus moves higher in the south, and by December it starts to sink into the southwest. And by the way, it is Capricornus, not Capricorn. That is for astrologers. The brightest star in the constellation is called Algety, which means the goat. This is a wide naked eye double with a separation of 376 arcseconds. The brighter star is magnitude 3.5, and the dimmer one is 4.2, and their combined magnitude is 2.8. Both of these stars have small companions, but they're too faint for us to see. This star is on your Explore the Universe certificate, so you will want to take a look at it. Beta Capricornus is another wide, easy naked eye double, also known as Dabby. This is separated by 205 arcseconds. It has a great color contrast, orange and green, just like cat's eyes. The brighter star is actually a triple, and there's also a tiny double in between the two stars. The third brightest star is Deneb Algety, which means the tail of the goat. We have a few other Denebs in the sky. Deneb is Arabic for tail. We have Deneb in Cygnus the swan, and Denebola, which is the tail star of Leo the lion, the giant cat. On the RASC double star list, we have Omicron. Nowadays, I hear it Omicron. Both of these stars are pale blue, and their magnitudes are 5.9 and 6.7. This one is just below naked eye visibility, so you'll need binoculars or a telescope to see it. Back about 2,000 years ago, when the zodiac was being invented, Capricornus had the winter solstice, which is the reason why we have the line on the Earth called the Tropic of Capricorn. And of course, the ancient Greeks managed to associate this constellation with another one of Zeus's love affairs. This star pattern represents Pan, who was the son of Hermes, who was the messenger of the gods. Pan had an extremely loud voice, and he could terrify people with his shouts. We get the word panic from him. Well, back to Zeus. He had fallen in love with Io, and one day, while they were together, Zeus caught a glimpse of his wife Hera coming up the path. Quickly, Zeus turned Io into a cow, of all things. When Hera saw the cow, she asked where it had come from. Zeus swore that he had never seen it before. Just now, the earth had given birth to it. Yeah, that's it, a newborn from the earth. Hera did not believe Zeus. She said how beautiful the cow was, and she asked if Zeus would please give it to her as a present. What could he do? Sadly, he turned Io over to his wife, who knew very well how to keep Io away from her husband. Hera put Io under charge of Argus, who was a watchman with 100 eyes. Argus could sleep while some of his eyes were still on guard. Zeus commanded Pan to find a way to kill Argus, as Pan was so clever. Pan approached Argus as a shepherd playing on panpipes. "Come sit by me, it's shady here," Pan said to Argus. Pan started to play a drowsy and monotonous song, a song about how the reeds became panpipes. Oh, how Pan had fallen in love with the nymph Syrinx. But Syrinx didn't love him. Pan chased her, and just as he was about to catch her, her sister nymphs turned her into reeds. Pan was enchanted by the sound of the wind blowing through the reeds. He told Syrinx, "Now you shall be mine." He cut the reeds and joined them together with beeswax to make the shepherd's pipe. The combination of this boring story and the drowsy music put all of Argus's eyes to sleep, one by one. Pan quickly cut off Argus's head, and Io was able to walk away, but still in the form of a cow. When Hera came back and saw that Io was gone and Argus was dead, she took Argus's 100 eyes and placed them into the tail feathers of her favorite bird, the peacock. Then she sent a horsefly to torment Io until Io could find Zeus and be restored to human form. Some years after all of this was the battle between the Titans, who were the elder generation of gods, and the younger gods. The younger gods were led by Zeus. In a vicious war that lasted for 10 years, the younger gods managed to overthrow the old ones and take control of the cosmos. Mother Earth was so outraged by all of this violence that she brought forth the terrible monster Typhon. Typhon was so powerful and uncontrollable that it could even destroy the gods. Typhon was a fearsome fire-breathing creature, taller than mountains, and with arms that possessed dragons' heads instead of fingers. The younger gods were taken by surprise at the approach of Typhon. At the last second, Pan shouted a warning, and he suggested that the gods disguise themselves as animals in order to hide from the monster. Pan turned himself into a goat, but in his panic, he jumped into a river where his rear end turned into a fish. All the gods started to laugh, and Zeus found this combination so ridiculous that he could not resist placing it up in the sky for all to see. We have only one Messier object in Capricornus, its globular cluster M30. This is magnitude 7.5, and it has a diameter of 11 arc minutes. M30 was discovered by Charles Messier with a 2-inch reflecting telescope. He classified it as a nebula because he could not resolve any stars. M30 is a little bit elongated. You can see it in this picture just a little bit like so. And its central nucleus is fairly dense. It's about 1.5 arc minutes in diameter. The cluster is about 40,000 light years away from us, and it's 100 light years in diameter. It's fairly ordinary as globulars go, but it's still a nice sight, and right now it's quite well placed for observing. Our sea goat has a beautiful barred spiral galaxy, NGC 6907. This is seen nearly face on. Its magnitude is 11.4 and it measures only 2 by 2.5 arc minutes, so it appears just as a fuzzy spot. It has one spiral arm brighter than the other, and there have been questions about this little object here, which is NGC 6908, whether that's just a bright spot in the barred spiral arm, but it's about 40 arc seconds away, and it's been found that NGC 6908 is actually a small spiral galaxy that's superimposed on the northeast arm of NGC 6907. M72 is another globular cluster. This one is really in Aquarius, but it's a lot easier to find by star hopping from Capricornus. Its magnitude is 8.6 and it's 3 arc minutes in diameter. This is very loosely concentrated, and with an 8-inch telescope, you can resolve easily hundreds of stars. M72 is about 60,000 light years away, and it measures 35 light years in diameter. M75 is another globular cluster. This one is really in Sagittarius, but again, because it's so close to Capricornus, it's a lot easier to find it that way. M75 is almost 95,000 light years away. It's one of the furthest of the Messier globulars. Its total luminosity is 160,000 times the brightness of our sun. It's only 6 arc minutes in diameter, and its magnitude is 8.5, so it's kind of small and kind of faint. If you're not sure whether you've found this one, you probably have. There are a whole lot of meteor showers associated with Capricornus. They peak in the summer, in daytime, so we have little chance of seeing any, and most of them have an hourly rate of 5, so it really isn't even worth worrying about. And Capricornus has 5 stars with known planets. And there are a lot of galaxies in our sea goat. Most of them are very small and very faint. My 8-inch telescope's limit is 13.5, so if I'm determined, I can find some of these. NGC 7017 is a lenticular galaxy, which means that it's between a spiral and an elliptical. It measures 0.8 by 0.6 arc minutes, and its magnitude is 14, so this one really will be a challenge. From what I've found, this is actually a pair of galaxies with the same NGC number. NGC 6903 is another lenticular galaxy. Its magnitude is 12, and it measures only 2.7 by 2.5 arc minutes. NGC 6924 is only 2 by 1.7 arc minutes, and its magnitude is 12.8. Don't even bother for this one. NGC 7030 is a barred spiral, which is really, really tiny, only 0.9 by 0.7 arc seconds, and its magnitude is 14.5. It was discovered in 1885, so I figure with our equipment, we should be able to find it. The ancient Greeks apparently had sea goats, but very little was known about them. I did manage to find a story that explains one of mythology's most mysterious features. The story begins with the sea goat Prychus. He was created by Kronos, the god of time. The immortal Prychus shares Kronos' ability to manipulate time. Prychus was the father of the race of sea goats who are known to be intelligent and honorable creatures. They live in the sea near the shore, and they can speak and think, and are favored by the gods. Eventually, the younger sea goats, Prychus' children, found their way onto the shore. The sea goats seem to naturally be drawn to the shore. They can use their front goat legs to pull themselves onto the beach and lay in the sun. The longer they stay in the sun, though, the more they change from sea goats into regular goats. Their fish tails become hind legs, and they lose their ability to think and speak, and they eventually become the goats that we know today. This upset Prychus a great deal. As the father of the sea goats, he was determined to make sure that his children never got to the shore. If they do, he is afraid that they will become mindless animals who can never return to the sea. After losing several of his children to the land, Prychus decided to use his ability to reverse time to force his children to return to the sea. During this time reversal, everything on Earth except Prychus reversed itself to where it previously was. As a result, the goats reverted back to the time before they went onto the land. Phrixus was unaffected by this time shift, so he was the only one who knew what was to become of the sea goats. He tried to warn them, even forbid them from setting foot on shore, but no matter what he did, and no matter how many times he reversed time, the sea goats eventually still found their way onto land and became regular goats. Phrixus finally realized that he could not control the destiny of his children, and that trying to keep them in the sea would never work, no matter how many times he tried to start over. He resigned himself to his loneliness without his children and chose to no longer reverse time. Instead, he allowed his children to live their lives out to their own destiny. In his misery, Phrixus begged Cronus to let him die, as he could not bear to be the only sea goat left. Cronus instead decided to allow him to live out his immortality in the sky as the constellation Capricornus. Now he can see his children from his place in the stars when they're up on the mountaintops. Now we're going to take a look at the first constellation of the zodiac. Who knows what that is? No astrologers here? Okay, well, we can tell just by looking at it, can't we? I mean, well, that's obviously that must be, those must be, again, oh well. Aries marks the vernal equinox, or the beginning of spring. This is the place where the sun crosses the celestial equator. The ancient people needed a marker of some sort to indicate the beginning of spring, and the only stars in that particular place in the sky are the dim ones that we now recognize as Aries. Almost 4,000 years ago, this position was an important one, and it will be again in the distant future. Because of the slight wobble of the Earth, known as precessions, this point has now moved into Pisces. The vernal equinox is the point from which we measure right ascension. When you look at your star maps, you will notice that 0 hours is in Pisces, and that's the reason. 0 hours used to be in Aries, and for historical reasons, the vernal equinox is still referred to as the first point of Aries. As is true for all the zodiac constellation, we can only see it in the sky during the opposite season of the year. So in this case, the best time to observe Aries is in the autumn. The ecliptic runs through Aries, so planets can also be seen in this area of the sky. The name Aries is Latin for the ram, not to be confused with the Greek god of war, Ares, which is spelled differently. King Athamas and his wife Nephthali had 2 children, a son named Phrixus and a daughter named Helle. Nice names. As time went by, Athamas fell in love with another woman, Ino, so he left his wife. But Ino was not in love with Athamas, she was in love with Phrixus, but Phrixus did not love Ino. This rejection made her very angry, so she tried to kill Phrixus and Helle. At the very last second, the god Hermes sent down a beautiful and powerful golden ram who could speak and reason. Phrixus and Helle both climbed onto the ram's back and were carried off through the air. Did I mention that the ram could fly too? Poor Helle couldn't hang on though, and she fell off, landed in a river, and drowned. There's a city near Istanbul called Hellesport, which is named after her. Phrixus managed to hang on, and he was carried to a land near the Black Sea called Colchis. Now that the golden ram's work was done, the ram commanded Phrixus to sacrifice him to the gods and remove his golden fleece. Phrixus did this, and he presented the golden fleece to the king, who was delighted with the gift. The king hung the fleece in the sacred grove of Ares, where there lived a dragon who never slept and who guarded the golden fleece. Apparently it was a purple dragon. We are told that the fleece shone so brilliantly that by night it bathed the surrounding countryside in a warm golden light. That's your first instance of light pollution. This brave and generous lamb was given an eternal place in the sky as the constellation Aries. It is said that the constellation is a dim one because at the time the ram was mortalized, it no longer had its brightly shining fleece. To find Aries, look to the south and find Orion. Follow up the stars of his belt to Aldebaran, which is the eye of Taurus, the bull, and keep going until you find the Pleiades. Between the Pleiades and the Great Square of Pegasus, we find our ram. The brightest star in the ram is Hamal, which is from the Arabic al-Razo Hamal, meaning the head of the sheep. This is a yellow giant star, magnitude 2, and it's 75 light years away from us, and it's about 75 times the brightness of our sun. The second brightest star is Sheraton on his left horn. This is a pearly white star. Its magnitude is 2.6. And along with this star, they were known as the ones that butt because they were the ram's horns. Hamal and Sheraton are the stars that you'll want to look for when you're doing your Explore the Universe. The second horn star is Mesarthim, which is one of the best known double stars. It was one of the very first double stars ever to be discovered. It was found accidentally by Robert Hooke in 1664. He was following the motion of a comet when he found this beautiful double star. The two stars are separated by 7.4 arc seconds. They're both yellowish white, and the individual magnitudes are 4.5 and 4.6. This is on the RASC double star list, which says that they look like moth's eyes. Well, I don't know what moth's eyes look like. They must be really tiny, so I cannot comment. There are a lot of other double stars in Aries, so take out your telescopes and binoculars and see what you can find. There is an asterism of stars over Aries' back called Musca Borealis, or the Northern Fly. It used to be its own constellation, and at one time it was a swarm of bees, but now it's part of Aries. My battery is running low. Keep going, all right. Close. Plug in. There we go. NGC 772 is a spiral galaxy 2 degrees southeast of Sheraton. It's 11th magnitude, and it measures 5.3 arc minutes. In this image, you can see the two arms, and the one on the northwest is fairly open. The galaxy is about 200,000 light years across, which is a lot bigger than the Milky Way, which is about 100,000 light years across. This is about 100 million light years away, and it's moving away from us at a speed of 2,400 kilometers per second. This bright smudge at the bottom of this picture is elliptical galaxy NGC 770. It's about the same distance as 772, and it's a member of the same group, possibly a satellite galaxy of 772. NGC 697 is a small spiral galaxy. It's only 2 by 1 arc minutes. It's only magnitude 11.8, so it's faint, but it's actually not that difficult to see. It's elongated east-west with a bright core, and this one's also known as NGC 674. I have no idea why. Another faint spiral galaxy in our RAM is NGC 972. In any other constellation, this would be a challenge, but in Aries, it's the brightest thing I have for you. Its magnitude is 11.3, and it measures only 2.7 by 1 arc minute. You should be able to find this in an 8-inch telescope. And if you use averted vision or maybe averted imagination, you might be able to see some spiral structure. Obviously, this one requires a lot of aperture and really dark skies. NGC 877 is another spiral galaxy. It's only 1.8 by 1.2 arc minutes. It's that one up there. Also visible in this image is this NGC 876, which is 1.7 by 0.6 arc minutes, and its magnitude 14.5. And over on the right is a little smudge of a galaxy. This is PGC 8739, not NGC, it's PGC, stands for Principal Galaxy Catalog, which is an astronomical catalog that was published in 1989. This galaxy is only 1 by 0.5 arc minutes, and its magnitude is 14.9. Aries has an irregular galaxy, NGC 1156. This is another one that's really small and dim, 2 by 1.5 arc minutes, and its magnitude is 12.5. And this weirdly shaped galaxy will definitely be a challenge, but if you do manage to find it, bump the power up and you'll see its boxy shape. And there were a lot of meteor showers associated with Aries. Look, the daytime Aretids, like really. And you'd think with all this going on up there, we'd have a chance at seeing something. October is a good month for observing our ram and our sea goat because now they're placed fairly high in the sky and it's not too cold yet, depending on what time you're out. So on the next clear night, get out there and take a look at Capricornus and Aries the ram. No ifs, ands, or buts. The end.
Thank you very much, Gail. I'll put my slides up. Is that it? There you go.
Sorry about that, Dennis.
Sure, it's up there.
Sharing screen to the people online.
Oh.
There's.
All right. Again, thank you very much, Gail. I found, especially the first part, a very moving discussion, so.
That's bad.
There we go. So again, this evening, this is the agenda for tonight. We have a beginner session. Again, thank you to Gail Wise for doing that. Again, myself doing the welcome announcements. What's up is Brian Stock tonight. And then we've got a break. The cafeteria is supposed to be staying open. So that's why the break's set up the way it is, followed by what's new. And then our main presentation by Dr. Mark Buey. And then for those that wish to, we can go to Boston Pizza afterwards for a get together. Okay. So announcements, just some things. Again, the U of M, Lockhart Planetarium is available, open. I want to talk briefly about our observatory committee. Dr. Michelle Boyce is in charge of that. Scott Young's also quite active, two of our council members. And some of the things that we've asked them to do at the last council meeting is to go out and research a few things, look at, in particular, Glenlee, how we can make Glenlee better for use by the members of the RASC Winnipeg Center. Really, from an educational perspective, what are some things that would generate more use out of Glenlee? The second thing that we talked about was look at and look towards the northern part of the city, the north of the city, for both an observing site for the RSC members, as well as an area that would be where we might develop some partnerships for doing public outreach. So for those in the room who may not understand the difference, so when we talk about public outreach, it's going to be just like what we're doing tomorrow with the eclipse at Assiniboine Park. We as center members and volunteers, we're going to do things out in the public in an area that anybody can come to. Whereas if it's just for the center, the RASC members, for instance, in Glenlee, that's really reserved for the center members. It's not designed or meant to be open to the general public at this time. So those are the two main things. There's some other things that were discussed about for the committee to go back and research and look at. And again, it's for just developing more. And if you're wondering why we're talking about an observing site north of the city, we have Glenlee. One of the things we experienced with our binocular group, binocular users group, is that they actually did a lot of it up in Birds Hills Park. And it worked very well for that group of people. So we know there's an interest in the membership. So we want to see what we can do to build that up and make more areas available. Okay, just as a general idea. We have no ideas what it's going to look like. We've asked them to go and take a look at things and come up with some ideas and then bring back to council. And we'll share that information as we go along, or the committee may reach out to the general membership for some feedback in some of the areas. Sprucewood Star Party was 14th, 17th of September. 73 people attended. And our last evening turned out to be our best evening. It was a little chilly, a little damp, but it was certainly a very, 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 very clear night. Astrophotographers were going nuts. The big scope was out. Jay brought out a great big scope. That's a 24-inch. Jay's, yeah, it was a 24-inch scope. People were climbing up the ladder, getting some incredible views. Just a really good time, enjoyed by all. So again, that's our annual event. It happens every year in the fall, depending on when the new moon is. And we have to offset when we do it, because we also do public outreach for the park with the Friends of Spruce Woods. But it was very, very well attended and worked out very well. So just wanted to share that. We put that online out to all the membership. Friends of Spruce Woods has asked for photos. If you've got any photos that we can share, anybody who's been out to Spruce Woods at any time for any event, astrophotography, things like that. They'd like you to share that with you. There's an email that we can forward it to, and it's just part of the working relationship that we're really developing out there with Spruce Woods, the Friends of Spruce Woods, the park, as well now that it's designated as a dark sky preserve. We're recruiting for a fundraising committee member or chair in particular. If you have any questions or any interest in doing that, Damon is our person over here. Damon, you want to hold your hand up if they got any questions? Damon's not on the fundraising doing that, but he's put together what we're recruiting for and what we expect it to look like. So he'd be able to give you some answers or maybe even forward to you what we're looking for. And if you want to talk to any of the council members, same thing, let us know and we'll send you the information. Explore the universe. Stan, did you want to actually say anything about it? I'll bring it to you.
Because my past situation, I haven't been very active with the group, so I'm kind of in recovery now. But later on, as we get further on in this season, we're going to do things. Now, I'm also sitting on the observatory committee, and what we're doing is we're exploring more ways to be able to use the observatory. So probably what will happen with those two, a collision of those two groups, where we will. I'll be helping to promote more of Explore the Universe by us meeting and doing things out at the observatory. There's another section to this, in that the councillors are going to be asked to take over and be in charge of a members' night. The members' night often be like tomorrow night, the night after our meeting, and so that will be on those opportunities. There may be times that we know for sure. Things will be probably that day or that night. So, you know, like but maybe what we can do is then do a meeting during the daytime, where we can go over things like telescopes and how you do star hopping and how you do many of these different things. So there's kind of like going to be a conglomeration of a number of different things associated with that. That's the first thing we want to make. The second one I wanted to make was during Gail's talk, you'll notice she's often talking about the size of the objects. She's talking about the essays. I wanted to just mention this. So she'll be saying the M30 was what? Five arc minutes, and you know kind of think relativistic. What does that mean? Well, the moon is 30. So when you're looking for these objects, you start to realize that essay list and the objects that it's pointing out are actually quite large. So they don't need, you know, to have 200 power to be able to find them. Actually, and then she'll get into other ones where she'll talk about them being quite small. She's talking arc seconds. She's referring to the fact that these, like the planets, come in arc seconds. And Jupiter, you know, sometimes over 40, 45 arc seconds. So you can sort of relate to her discussion. And so next time she does a presentation, think about that portion of it. If she's saying it's 5 arc minutes, you think, well, that's a sixth of the width of the moon. So when you use your scope or binoculars, high-powered binoculars, maybe, you think that's how big that is. That's how big the object would be. So it would be about 1/6 of the size of the moon. So you can realize that a lot of these objects are actually quite easy to find. And thank you, Gail, for always identifying which of those stars and objects are involved in.
Thank you, Stan. Just mentioned about, we also have a telescope loaner program that's available to anybody who's a member. Mike Caracas is the person you would contact for that. And generally speaking, how that works is you let them know that you're interested in a scope. The members, you get told when you join up as a member, you'll find out what the different scopes are and what are available. And then you would contact Mike, and if it's available, you got to do a little bit of paperwork. And then Mike would keep that scope for usually a month. And if you wanted to keep it longer, you'd have to wait to see if anybody decide to borrow that scope again. If they don't, then you could again extend the time that you're going to keep the scope. So we have several different types of scopes, and we also have solar scopes. So if you can only observe during the day, the solar scope is an option as well. What else here? Partial eclipse. So I'm going to show a little. We're going to put Scott's. Scott would normally be here to talk about it. For those who know Scott Young, he works at the planetarium. But Scott Young will be up on a video that he pre-recorded because Scott was down at the launch of the Psych probe. So this morning down in Florida. So he's actually not working his way back. So he's available tomorrow morning to be down at the Cinnamon Park. So we'll see a little bit more about that. But what we will say is tomorrow we'll have these for sale for the general public. They'll be $5 a piece. We limit it to 4 per family. If you're an RASC member tonight, if you come over and see Damon, every member is entitled to 1. You can get 1 for yourself as a member of the RASC. So just so you know, and 2024 budget, just to pass on, just to let everybody know that it'll be presented next meeting. Council's reviewed it, looked at what we're doing next year, and it'll be presented next year or at the next meeting, just for everybody to see, make comment. Budgets aren't voted on because that's the council's responsibility to administer the budget, but at least we want to make sure everybody sees what's going on and the different areas that we're working on. I did put it on there, but Ed is still trying to work with the province on our flood claim that we put in for when there was a flooding down at the observatory. So we're still working through that process. Anybody working with the government is quite interesting. Of course, now we've had a change of government, so we'll see how that impacts it. So, and I also just want to note, we've got 3 visitors up in the back there, young visitors. Hello, and just want to say hi and welcome you. And really think it's cool. If you're here to learn about astronomy a little bit, I just want to point out, I don't want to put anybody on there. But we have 2 doctors. If they want to stand up, please. Just want to stand you up so that these young ladies can see you. Please stand up and wave to the young ladies at the back. So just so you can see, there's a place for everybody. And if you are interested in sciences and maybe what to do, I'd say if they have a minute at the break, just take a minute and talk to them a little bit, just to see. It's a long path, don't get me wrong, but you're young and you can think about it. Just think about it. So astronomy is one area that could be looked at, and I encourage you to think about it. Anybody got any questions for me? Super. Just a reminder for the members. Oh, sorry. Go ahead.
I had a question. Can members collect solar glass tomorrow at park?
Yes, they can.
Okay, thank you.
You're welcome. Sorry, I should have checked at the chat. Just double checking. Great. So groups.io, this is how we communicate with our membership. This is just how to get in there. We put it up every time just so like we had about 25 new members recently get registered on it. And so just like to tell people about it. And in there's different groups and binocular groups, armchair astronomy. So if you really like to just talk about stuff like that, an area where you can do that. And there's multiple different groups that you can join. Members observing night, we'll send out an email tomorrow if we're going to do it. The weather tomorrow is a bit questionable. We're hopeful during the day that, beginning of the week, they were talking about rain for tomorrow. Now it looks like cloudy or sunny with cloud. What that means, we don't know tomorrow. So it's a little hard, but the big thing tomorrow, there's a lot of people that would be the ones to volunteer on lead members night will be involved with the eclipse going on tomorrow. So we'll send out, we'll send out an email to the group on groups.io if it's going to happen. And I'm just gonna back up because we need to put Scott's video up here. You got Scott's video? It was emailed to it. We'll just take, maybe what we'll do is we'll get Brian and I'll email it to you.
Okay.
All right. So I will introduce Brian. Brian Stack will do what's up. Welcome, Brian. Friday the 13th.
Trying not to think of one. Yeah. Just give me 1 minute here. I've found that it's not good to run it from the drive, because it, like from the thumb drive. 'cause it won't
Does
be-
bring back some old memories? Our first room.
Okay, I think we're good. Okay, let's give it a-
There you go. This should be good. All right, can everyone hear me? Okay, so we'll talk about little, but what's up for October 2023. The weather looks pretty good, but I'll go in greater detail. Like I said, this kind of brings back some old memories. All right. Okay, we'll talk a little bit about the planets, and we'll just keep it simple for the planets here. The only planets that are going to be really visible in the evening would be Jupiter and Saturn. There's other planets, Uranus, but those are a little too small to find, but we do have some reference points. Mercury and Mars, those planets are pretty close to the sun, so they're not really quite visible. Maybe with the solar eclipse, the partial solar eclipse that we have, maybe they'll be viewable, so that'd be interesting to see. All right, so tonight's events, and I'm going to, can I move this? Well, move this over here, so you guys have a better view of this. Okay, there's a lot happening. Of course, tomorrow we have the partial solar eclipse. I'll talk more about that later. We do have these zodiacal lights that's going to be visible starting today for the next 2 weeks, but it's only going to be in the pre-dawn. Of course, the new moon's on the 14th. That's nice. We do have, of course, and why am I looking? I could just look down here. We do have 2 meteor showers. One is really going to peak on the 20th. The Orion meteor shower that's going to happen. Weather forecast for that looks pretty good, but again, I'll talk more about it later. Of course, we have Saturn that's going to be 3 degrees north of the moon. The full moon is on the 28th. And we do have a partial lunar eclipse here happening, but it won't be visible in the western part of Canada. I was debating about whether to mention it or not, because it's not going to be visible, but I'm just going to mention it anyways. It'll be more towards the east. Okay. And of course, on October the 30th, we have the moon will be 1.1 degrees south of the Pleiades system. Okay. Okay. There's something. It is Friday the 13th. There. Okay. So like I mentioned before, I'll talk a little bit about the annual solar eclipse here. It's only going to be roughly, from my calculations, going to be about 43% of the cloud coverage. I don't know if you see it, but I'm trying to simulate how much of the sun is going to be covered. Again, it's going to start at, we said at 10:28 a.m. tomorrow. The maximum is going to be 11:42. It'll be interesting to see if any stars are going to come out, if it's going to be dark enough. Of course, it'll end about roughly 1 p.m. But according to the weather, and it's still kind of holding up for tomorrow, we're roughly going to see maybe 25 to 40% cloud coverage, but maybe more than enough to see the eclipse or the partial solar eclipse. Okay, so for tomorrow night at members night, I'm trying to show everything here in one shot. This is early in the evening. We do have a little bit of the Milky Way here. Then we have the Pegasus here. I just kind of list basically some of the stuff that's going to be happening here. Some of the things that I don't really mention is double star cluster, which is kind of nice to see. They're big objects to see. M81 and M82, I don't normally talk about it, but it's pretty close to the Big Dipper. Of course, we have the Pleiades and Jupiter. This won't really change for the next month. And of course, we have Saturn. So Saturn and Jupiter, but if you go out there for Jupiter, you kind of see it's really high in the sky. So there's less atmosphere for you to look through. So that makes it quite easy. So those really are only the two planets. Again, there's more objects to be, and of course, everyone has apps, right? So you're probably going to look at the apps, but I don't really use it. I just know it's out there and I just look for it. Okay, so the Orion, the winter constellation is going to be happening roughly just a little after 1 p.m. This is one of my favorite constellations because we have M42, one of the larger objects. This is one of the first objects I've seen through a mere 3-inch reflector type telescope. It was pretty sad, but I was pretty excited. One of the first objects. So again, it won't happen until a little after 1 p.m. I mean 1 a.m. Sorry. And of course, as I mentioned here, I don't have it here. Yeah, so we got Pleiades and Jupiter. Again, this part here is not going to really change much over the month. So that would be kind of nice to see. Okay, I did say there's a meteor shower peaking on, I said October the 21st. Okay, that's actually in the pre-dawn. So if you think of October the 20th, you stay up long enough. But the moon is going to set early in the evening, so we don't have anything to worry about. So I think it would be quite nice. Again, if forecast holds, it's going to be mostly clear, especially on Saturday. The low is going to be 5 to 7, so it might get a little chilly there. But I would say it looks pretty good. I'm going to mention too, there is another meteor shower that's happening. It won't start till the 20th, but it's kind of overlapping, so meaning that there's a greater chance of you guys actually seeing something. Of course, what did I say? It peaks around November the 20th. It's only 5 meteors an hour, but one of the nice things about it is it's fireballs, right? These are the ones that are really spectacular to watch for. Okay, so what's going to happen on October 31st on Halloween? Well, again, we do have the Pleiades and then we have Jupiter. So just kind of see what's going to happen on Halloween. I do have my costume picked out. I was going to wear it tonight, but maybe not. But there is some parties coming up, so I'm looking forward to it. Okay, what about the forecast? Well, this is roughly a 10-day forecast. This is the temperature-wise. I am going to change a little bit about this time here. So it is going to get kind of cold. One other time, it kind of showed that, see, it kind of get almost pretty low to 0 here. But in another way, with another graph, and I've taken stats for a couple of years, so I get used to looking at this all the time. But in all, it's pretty much common sense that in the next couple of weeks, it's going to get a little colder. So, and yes, I'm going to say the S word, snow, but it looks like it's not going to happen until well into November. All right. So again, for the cloud coverage, we are going to get some clear skies. Well, again, this is okay. So Saturday, we're looking at roughly we're 12 p.m. for able here. It did change a little bit. It's now up to 40% cloud coverage right there for the partial solar eclipse tomorrow. But again, so it looks quite favorable. Hopefully, we'll have a nice little break there to see it. As for the cloud coverage, we already see here, you can see there's going to be some rain well into Wednesday. So, but as for the meteor shower happening on Friday, so we are, this again changed a little bit. It was a little clearer, but again, we're just going to have to wait. So what I've done is I'm going to do something a little different, kind of put it in a more easier view. a lot of people say, well, I can't really read those charts, you know, and it's a little hard to see, and me trying to break it down, so I'm gonna break it down this way. So as you can see here, in all, the bottom line is, what's gonna happen is, we're gonna have some partial clouds. I only picked the nighttime, because I think that's the only time we really care about. During the day, I don't think it really matters. Yes, Dan. You know, I wasn't gonna do the day, because I don't really care, because I'll be in my office working, so it really doesn't matter. Of course, in the winter time, you know, I'll never see daylight. I'll just only through my window, and that's it. And time you go home and get to work, it's always going to be dark in the winter time. But you know, again, as you can see here, we'll get quite close to zero here, but it will never get too cold. It never can get reached to zero. But I did look at another model to see what the forecast is going to be in general for October and November. Like I said, we're supposed to expect some above seasonal temperature in October, so hopefully that's going to happen. I heard the news, something's going to turn our favor in terms of temperature, but I'll look a little bit more closer to that. As November, yes, we're probably going to expect snow, but maybe a little bit of luck, we won't get snow. But I think this is an extra way to kind of give you a picture about how the night sky is going to be. So Wednesday, Thursday, don't worry about this. This is actually going to be cloudy, so wave that off. So yeah, it doesn't look too bad for the weather for us, but it is going to get a little chilly. I'm going to try it tomorrow, going out a little bit to see how cold it's going to get. But anyways, that's up. That's what we have that's what we have for October 2023 for What's Up. Thank you. So is there discounts for past presidents for the glasses? No? Okay, we get one free one. Thanks.
So we just got to upload a video from Scott to talk a little bit about tomorrow and what it's going to look like here locally.
Okay, I don't know, just give me a minute. I'm not logged in, so just hopefully that'll work. Oh,
Very good. All right, so we're going to hear from Scott.
okay, just give me a minute.
Hi, everybody.
Yeah.
This one's.
Scott, I'm sorry, I can't forget. Can you turn off that microphone?
Yeah.
But I want to hear them.
It should be on. Camera's right here.
Okay, great. So. Thanks for pointing. I think I'll be okay. All right. Thanks, everyone. Thanks for coming. So I will do two stories at different depths for in the news. The first story I'll do is this is. Yep, there we go. So it was a NASA news release that was written by Abby Donaldson on October 11th. And the title was NASA's Bennu asteroid sample contains carbon and water. And so here we have an image of the top of the containment capsule for the sample that was returned from asteroid Bennu. So this is returned by the OSIRIS-REx mission, which stands for Origins, Spectral Interpretation, Resource Identification and Security dash Regolith Explorer. And so this is a mission. Oh,
No, you
no, I'm good. Moving around too much. So this is the first US mission to collect a sample from an asteroid. It was launched in September of 2016. It took a few years to get to asteroid Bennu. And then it did a few orbits where it mapped the surface with LiDAR and imagers. It touched down and collected the sample on October 20th, 2020. And then it departed from asteroid Bennu in 2021. And then it, from a very large height, dropped the sample capsule down to Earth in September of this year. And these are some of the very first results from that sample. OSIRIS-REx, the mission itself, has continued on to another asteroid called Apophis. All right, so in terms of Bennu, the asteroid, it's a near-Earth asteroid. It was originally discovered in September 1999, so it's been known for less time than I have been alive. Its average diameter is 482 meters. It has a current distance from Earth of 0.62 astronomical units. It has an orbital period of 1.2 years, an orbital eccentricity that's quite high of 0.204, an orbital inclination of 5 degrees relative to Earth's orbit. It is classified as a potentially hazardous object because in about 31 years, it will have a very close approach to Earth. And so here we have this website is incredible. This is the problem with my website is I start doing research and then I go down rabbit holes. And then I panic to format my slides right at the very last minute. But this website is really incredible for visualizing where everything is in the solar system. But this is asteroid Bennu. We have some other asteroids. This is OSIRIS-REx, and we have Earth. And every single blue dot in this image is another near-Earth asteroid. Nope, too much. This one. Okay, so here's a top-down view of the inner solar system to give you a sense of where everything is. So we have the sun. In purple, we have Mercury's orbit. In orange, we have Venus's orbit. In blue, we have Earth's orbit. Asteroid Bennu is here. It's not inside Earth's orbit, it's just below the plane that we're imaging at. Apophis, which is where OSIRIS-REx is headed next, is right over here. And again, all of these blue dots are asteroids. This is a close-up image of asteroid Bennu. And so before OSIRIS-REx went to the asteroid, we thought it was roughly solid with lots of boulders on top. But then when they landed on it to kind of, they had a mission where they just kind of like dipped down, scooped things up, and then like use their propulsion to propulse them back from the asteroid. And if they hadn't turned it on, the entire mission would have been swallowed up by the asteroid. It's very loosely bound rocks. So they're bound together gravitationally. But they were, all of the analogies are like, it's like a ball pit. And so it's really, really loosely held together. And if they hadn't turned on the propulsion, OSIRIS-REx would have just been like swallowed up into quicksand in asteroid Bennu, which is unexpected. So it's held together very loosely. So, Oh dear. There we go. Okay, so why did we go to asteroid Bennu? And so we wanted to investigate how our solar system formed and how the planets formed, and in particular, how life began on Earth. And so we have some hypotheses that asteroids and comets brought water and carbon-rich molecules onto Earth. And the other thing is that because there are no geological cycles, there's no magma, a lot of the rock that is on these asteroids is unprocessed. And so it should be, in theory, in the very similar state to the state that it was in when the solar system first formed. And so they're really old. And so if we can get a sample of what these rocks are made of, it'll give us a sense of what the very early solar system was made of. And so the science goals here are to improve our understanding of asteroids that could impact Earth, to improve our insights into materials contributing to our solar system's formation 4.5 billion years ago, and to shed light on the role of asteroids in delivering water and organized molecular molecules to Earth. And so here, because Bennu is a near-Earth asteroid that might one day have impact Earth, knowing that it's a pile of rubble that might break up in the atmosphere is a lot less stressful than thinking of it as one giant 400-meter monolith. Okay, sorry, this is a lot of text. So this is a close-up of Bennu's surface taken by Polycam on the OSIRIS-REx. The field of view here is about 65 meters. So that should give you a sense of the boulders. And so Bennu was chosen as an asteroid to go visit because we thought it was carbon rich. When I say we, I mean the scientists on the team. I had no part in this. But scientists thought that it was a carbon rich asteroid, in large part because it had a similar color and texture as carbon rich meteorites that have fallen to Earth. It also had similar spectral properties that often contained organic molecules. So these materials were thought to be forged in large dying stars. So as massive stars fuse elements in their cores, we get heavier and heavier elements and atoms. And then especially in supernova, we can get really heavy metals, really heavy atoms. And then we get these complex molecules from interactions in those high energy environments. So those materials would have been formed in previous generations of stars. They would accumulate in a giant cloud of gas and dust that would eventually become our solar system. And so because we think asteroid Bennu wasn't processed or doesn't have a lot of geological evolution, we think it's an ancient relic of our solar system. So potentially more than 4.5 billion years old and made up of some of the solar system's oldest materials. The present day composition was already established, scientists think, within 10 million years of our solar system's formation, which was about 4.5 billion years ago. Bennu is hypothesized to have broken off from a much larger carbon-rich asteroid, about 700 million to 200 billion years ago. It was also thought to have formed in the main asteroid belt, so further out between Mars and Jupiter, and has slowly drifted closer to Earth. And so because these materials are so old, Bennu may contain organic molecules similar to those that could have been involved in the start of life on Earth. And so there's a debate about whether Earth had simple carbon and a lot of the chemistry happened here, or whether a lot of the chemistry happened in space and then was brought to Earth via asteroids. All right, so now that the sample is on Earth, it landed in a desert in Utah. We want to be very, very careful that nothing on Earth contaminates this pristine sample. So here we have a chamber with gloves on the outside that the scientists use to open up the capsule and to do all of their analysis to really make sure that there's no cross-contamination between stuff on Earth and stuff that came from Bennu. So the material collected by OSIRIS-REx will be carefully curated at NASA's Johnson Space Center, and it'll be shared with scientists. The mission was really successful. They got even more material than they were hoping. So a portion of it will be preserved for future generations. And so in generations of science, hopefully we'll have even better instruments, even better insights. And so if you go back and reanalyze some of this material, you could hopefully learn more. The capsule was purged with nitrogen, so a lot of nitrogen was blown over the capsule. This is a gas that doesn't interact very much with other materials. So it made sure that the container inside of the capsule kept all of the contaminants out. And so the sample hasn't been completely weighed yet, but initial measurements said that we have about 8.8 ounces or 250 grams of material. This is the clean room with no arms inside of. I never did chemistry or biology, so this looks really fun to me. You can just stick your arms in there, and that way there's no cross contamination. So there's a clean room and custom glove box. You can analyze the asteroid dust from the initial disassembly for an early glimpse into the chemical, mineralogical, and physical characteristics and the rock types. So outside of the container, most of the rocks are dark powder and sand-sized particles. And so when they analyzed that, they analyzed it using 3 different techniques. So the first one was a scanning electron microscope, and that gave us information on the chemical and morphological analysis. They used infrared measurements, which gives us information about whether the rock is hydrated, so whether there's water built into the structure of the rock, and whether or not there's organic rich particles, and then X-ray diffraction, which is sensitive to different materials in a sample, which will give an inventory of the minerals, and perhaps an indication of how many minerals or the proportion of minerals that are there. Okay, so the result is that there is a high carbon content on asteroid Bennu, so our suspicions were confirmed, and there's actually a lot of water. So this could indicate that the building blocks of life on Earth could be found in the rock in the asteroid. So it's an exciting result. And then it also gets its own stamp, like many significant space moments. OSIRIS-REx gets its own US stamp. And the reason for the significance of this, as stated by the Postal Service, is by enabling scientists to study well-preserved rocks and dust from an asteroid, which are older than the most ancient Earth rocks. OSIRIS-REx may help answer fundamental questions. Where did we come from? How did life originate? And why is Earth a habitable planet? And so the return samples collected from Bennu will help scientists worldwide make discoveries to better understand planet formation and the origin of organics and water that led to life on Earth, as well as benefit of all of humanity by learning more about potentially hazardous asteroids. Okay, so that's story 1, and then really quickly, story 2. So James Webb has captured a beautiful image of NGC 346. This is in the Small Magellanic Cloud. It's unfortunately not visible from the Northern Hemisphere. And this was published by the James Webb team October 10th. And so this is a composite image between the near infrared and the mid infrared images. And so here we have blue, which represents silicates and sooty chemical molecules, known as polycyclic aromatic hydrocarbons, or PAHs. The red lines are warm dust. The bright patches and filaments are a number of protostars, so stars that are just being born. So we have several wavelengths here. And this is a follow-up on an earlier image taken in July, also by James Webb, but only in the near infrared. And so this image in July showed that there's a lot more star formation happening in the Small Magellanic Cloud and in this NGC 346. And this is a galaxy that is has much less metal than our galaxy. And so it's considered to be a younger environment because there haven't been as many generations of stars to enrich the environment with metal and heavy elements. And so the question is, how do stars form, and do they form the same way in this metal in an environment that doesn't have as many metals as our own galaxy. And so they weren't sure whether or not the dust would form. And so here in blue, we can see that there's a lot of dust and a lot of heavier elements. And so it showed, which is a surprise, it was more than they thought. Yeah, it's a good. Thanks.
Any questions there? Go ahead.
Sure.
What exact point in time did they realize that that asteroid was just a loose collection of debris?
So, okay, so the question was, at what point in time did they realize that the asteroid was just a loose debris? When they landed on it, from the sounds of it. So they had planned on slowing the mission down. So slowing it down, and they were gonna do a little, so they have this, they called it the tag something. And it was like the touch and go system. So it was an extendable arm that was gonna reach down. They were gonna puff some air and then grab some dust. And but they expected there to be resistance, and there wasn't, so they just kept going, which was completely unexpected. So it's pretty lucky that their system worked anyways. I wasn't able to include it. I'll maybe send it along to the email list, but I have a couple of videos of what happened, and they recreated with simulations the landing. And OSIRIS-REx, after touching down, did a couple more orbits, and you can actually see the landing site, and they like displaced, I think it's like tons of rock from the propulsion. Yeah, it's really interesting.
Follow up.
Yeah.
Do they have they changed the models of how an impact of such an asteroid might impact Earth based on its composition? My honest answer is I don't know. Although I suspect that I'm a lot less worried if that were to hit Earth, but I think it's still a big assumption to go from like that one's no longer hitting Earth to like none of them are, right? So there might be some large solid ones out there. But that one in particular, I'm less worried about. Yeah.
Again, thank you, Dr. Damian. So we're just getting set up for our speaker. Yeah, let's see over there. And just while they're doing that, I will do the introduction of tonight's speaker. Tonight, we have Dr. Mark Dewey, and he is a graduate of the Lunar and Planetary Laboratory at the University of Arizona in 1984. Dr. Dewey was a postdoctoral fellow at the University of Hawaii and worked at the Space Telescope Science Institute. He moved on to the Lowell Observatory, and he now works at the Southwest Research Institute in Boulder, Colorado. Buddha was a central theme of Dr. Dewey's research, starting in graduate school, culminating in the New Horizons flyby. He discovered the extended mission target, Arrokoth, and led successful occultation campaigns that showed Arrokoth was a contact binary prior to the New Horizons flyby. Much of his efforts these days are directed at detailed studies of small bodies ranging from near-Earth objects or near-Earth asteroids to Kuiper Belt objects using occultations that are now made possible by the Gaia Astrometric Star Catalog. Please welcome Dr. Mark Dewey.
Oh, thanks for the intro. Can you hear me okay?
Yes.
Excellent. Let's just hope that this dodgy hotel Wi-Fi hangs in there for this presentation. But let me share my screen. Can you see this?
Yes.
Yeah, perfect.
Okay, great. Okay, we good? Um, keep in mind, I'm happy to take questions at any time, but keep in mind, I can't see the chat while I'm presenting. So you'll have to just interrupt verbally. So what I'm going to do is to talk about the work that has basically has consumed my life starting in, it really turned a corner in 2017, right? Coincident with the Gaia catalog being released. And what we're able to do and study small bodies anywhere in the solar system that we want is it's a profound change for the scientific community. And of course, we've learned a lot about near-Earth asteroids, but because they get closer and they're easier to study. We've got radar imaging and lots of other kinds of observations, but the things at the very outer edges of the solar system just remain very difficult to work with. And that's most of what I'm going to concentrate on in this talk here today, and give you a little bit of a flavor for what this work entails and the kind of results that we get and what we're learning about the objects. And this is what I'm going to show you is just a very tiny fraction of the results that we've been pulling down in the past 6 years. So one of the main premises that that motivates all of this work, particularly in the outer solar system, is you've just seen some nice pictures and information from OSIRIS-REx and talking about Bennu, and this is an ancient object that dates back to the beginning of the solar system. But there was also wrapped up in that discussion a little bit the fact that, oh, this piece broke off from a larger object. Well, did that object break off from another object? So there in the asteroid belt inside the orbit of Jupiter, there's a lot of collisional processing that's taking place. And it's going to take us a while to kind of figure out which parts had to do with formation, which parts had to do with the evolution of the body themselves, and which parts had to do with collisions. When we go out to the outer solar system, there's a special population of objects of which Arakoth, which you see in an inset in the upper right corner, these objects, by all accounts studied by the dynamicists, these objects we
Yeah.
Okay, folks, those folks that are online, we've lost the doctor. And if he comes back on, we're going to, and what's suggested by some people here that what we'll do is we'll put the slides up and give people a moment to read them. I was gonna try and make commentary, but that seemed to get shot down pretty quick, so there we go. So the first slide is up, where he was kind of talking at the beginning here, so we'll just give you all a moment to review it, and then we'll move on to the next slide. Oh, okay. Erica, blazing a new trail. People online cannot see this. Good to move on. Okay. There's nothing I can do about that. I believe they're showing you how the oculations, when you take your oculations. And are able to get the shape vertical. Good to move on. And as Michelle, you probably couldn't hear that online, Michelle was pointing out that, if I understood her correctly, is through the oculation, moving the cursor, you're able to start getting the shape of the object. As you can see here, it's starting to show the shape of the object. Am I doing that correctly?
Yeah, they got a shape from, well, they had an expedition on Earth to try and get the shape of Area column and determine the environment around Area column before New Horizons got to it to make sure it was moving free. So they predicted the shape before they saw it.
Okay.
Now it looks like they're gonna use some more fancy equipment like James Webb to get better shapes.
Okay, and I'm not sure if you were able to hear that. So basically, Michelle was explaining that they did this is a model that they predicted, so that they had to see how the prediction would match what they actually found when they did it. So, and
Notice all the different dates that they had to do. Each one of those pictures is a different date because the object's tumbling. So you have to do it over and over and over and over again.
Yeah, there's a book on Pluto that I was reading.
oh, cool.
I saw the one.
Yeah, they had an expedition, it was cloudy, they had to do it again.
Yeah.
Yeah, there's several videos, yeah.
So again, I'll just go to the next one. So this looks like an actual picture. So as we saw on some of the forecasted drawings, the picture is quite close. I'm just gonna slide through this one because I think it would have to be explained.
That looks like modeling of how.
Oh, okay, yeah. So for those who are online, Michelle mentioned this is modeling of how they suspect it was formed.
Or this is a nice.
I'm not sure. I mean, the materials in the outer solar system is slightly different than the materials in the inner solar system.
Won't be fast.
No, it's okay. I just managed to read it all.
Oh, sorry.
No, that's fine. Well, it looks like he's talking about space platforms for more precision application for mapping shapes of hyperbuilt objects. Hopefully they can see this thing.
Yeah.
I don't want any more commentary.
What's that?
I don't know if you want any more commentary.
Yeah, no, if you got it. Yeah.
Well, basically, if you have a star, and you have an object, a very small object that passes by a star, it causes a dimming. If you look at it from different vantage points, that's how you get the shape, and that's what he's showing here. So knowing where the object is, knowing when an occultation is going to occur, observing a particular platform, you can get a shape. Then you can start to figure out what types of objects are out there.
So did the people, did the people, yeah, well, why don't you come on up here and then you can comment. So. Get the microphone.
Yeah, so I'm just going based on my knowledge of this stuff because I've been reading up on this quite a bit. Yeah, okay. So, I've been reading up on this a bit, and this looks like, much more advanced stages since, New Horizons probe. So for New Horizons, when they went past Pluto, they wanted to visit Arrokoth, which is the next closest object along their line of sight, but they needed to know the shape of aircraft and its type of environment. So the way you do that is basically on Earth, you have an expedition of a bunch of telescopes scattered throughout Earth. They know when that object's passing in front of a star, and they look at the dimming from different vantage points. And from those different vantage points, they can get the shape. So I believe what he's talking now here about is using other space platforms and so forth to try and map the shapes of the different objects in the type of that, and maybe answer the question of how many contact binaries are there, for example. Yeah, so that's, I believe, what all this is about here. You can just sort of read through and you can see what he's talking about.
It's using amateurs in this one,
Yeah,
including amateurs.
and in fact, I believe Scott gave a talk where he was actually looking at asteroids. And by observing them, you can also get the shapes of the asteroids, so lighting from different angles and so forth, where they are in the solar system with respect to the sun. Somewhat similar process, but now you can see the types of bodies he's given. Spinning. So they're trying to fit different shapes, I guess, to these distributions. To see what type of objects they are statistically. I'm just making all this up. So.
Doing a better job than I did.
I believe Lucy, is that not a probe?
Yeah, I believe so.
Yeah. Okay, isn't Lucy doing the mission between the Trojan giants? Trojans? Yeah, so I believe. So they might be able to predict the sizes of the objects of the Trojans before Lucy gets there.
Trojan asteroids.
Yeah, so you have Jupiter, and as Jupiter moves in its orbit, it has the Trojans. I forget which camp is which camp, but there's a clump of asteroids on this Lagrange points behind and forward, and they're called the Trojans. And it's supposed to represent some, but there's a cluster of asteroids that Lucy is going to visit. Lucy launched not too long ago. Other higher unlike object. Okay.
2021.
Yeah. My time confesses for me. Seconds is okay. Oh, Melanie, that sounds like another option.
Yeah. That's what it is.
Yeah. Let's compare it to one of the ones of our thought.
Yeah, the small little.
Yeah.
What are you saying there?
Yeah, you can see the lines now starting to get more and more sensitive. You can see recon, the different types of observations.
From different.
Yeah. I also think different observation platforms. And Sean is another one.
Yeah, only one.
How's that? No, that's something else.
This is a.
Okay, yeah, so he's talking about definitely talking about the Lucy encounter and determining the shapes of the objects that's going to be visited by Lucy. So there seems to be sort of a technique that's coming into maturity. So once Lucy gets there, we'll be able to verify the shape. other system.
Somebody still has, that's watching has got their microphone on. If you could mute it, please.
Zeros and transneptune objects.
Well, it looks like to me, what they're doing is comparing the data from Lucy, it's measured them to what the calculations are telling them.
Well, so Lucy's going to encounter these objects, and they're looking at advances to see the shape of the objects. And then Lucy will probably confirm those shapes. And I presume from that they can make a statistical model, and then it looks like we're talking about the Trojan trans-Neptune objects, which are basically like, who knows a trans-Neptune object? I believe.
That's where it ties in with
Yes.
Dr. Bewey.
Yes, so I'm just going to statistics from that and the experience to map hypergraph objects. The trans-Neptunians are in inner part of the hypergraph. So there's the recon, Lucy, stuff that was mentioned on the other slides. Which one? I don't know those. Probably not that size. Though. This is part of my community science.
Yeah.
But yeah, there were objects found by, it was a, objects found far out or further than our objects found by just, citizen science.
Yeah, it's interesting that that's a key part of this. So for those that are online, we will reschedule Dr. Bewey to give a presentation again at a later date. But we will finish just going through the slides. It won't take long now, so.
And so there's a few areas where amateurs, starters would be like real science.
Sounds like this is where
Yeah. This is still similar to how they found the shape of their top. They had lots of telescopes scattered across the planet to get this information. my wish list up there.
So any astrophotographer in the room,
Anyone want to try?
they didn't spend very much money on that.
Oh, yeah, so they use their interest too.
So it really seems like
Yeah.
the major purpose is to use multiple sources.
Yes, yeah, because you need multiple vantage points so you can sort of get occultation intensity profile of the object passing by, and from that, you can work out quite a bit of information about that object. Although it's interesting because you're using the Earth as a telescope in a way, it's the scale of things.
So this is the project, I suspect this is a project he's trying to put together.
Well, yeah, it looks like if you have cooperative groups, you can do quite a bit of this as citizen science, and it's not as expensive, I guess. But not necessarily citizen.
Right. Well, he's suggesting that $7 million to do the project. It's a big pitch for community science.
Quite the team.
Great mix there.
Yeah.
We'll get some contacts or things to look up. Ah, look at that. Is that J-scope?
Yeah, it's just
Unfortunately, Dr. Buey, we lost him. So, yeah, thank you. Thank you to Dr. Michelle Boyce for giving us a commentary there along the way. Just put in context with you. You know, and I was her lovely assistant. Bubbling along. So again, just a reminder to everyone before we shut down. Tomorrow, 9:30 is when we begin setting up. Scott said he'd be there about 9 o'clock at the leap. You can drop off your scope at the leap. They should have trailers there to help tow our stuff onto the site, the observing site, which isn't very far away, and then the parking lot. And we'll go to about 1 o'clock. And he also mentioned that even if you don't have a solar scope or solar setup, please come down. There's always things that if the weather's nice, and it is being promoted by the different news stations and that, there we could have a lot of people, and it really helps if you got extra people to kind of guide people to line up and not go running towards the scopes, because that's always something that happens sometimes. And guard the scopes from little kids, and but it's really cool. So again, that's going to bring us to the end of our meeting tonight. Just thank everybody and thank everybody who's online. And I wish you all safe travels, and a reminder for those who are interested, Boston Pizza. There's a gathering over at Boston Pizza on Covenant. So to those online, have a great night. Everyone else, good night.